My name's Neil Hicks. I'm the Fluid Systems Manager. I started here 4 years ago when there wasn't anything out here. And me and another guy pretty much designed all these fluid systems and took this nice launch pad and adapted it for a Falcon 9.
He's always making fun of me with the belly button lit. I think it's the shirts I wear and the fact that I have hair on my belly and she doesn't. My theory. And somebody told me once that
Who's got the radio?
Or belly button like that is because as you get started and you got the hair.
All right, so we're yeah. It's like what? All right, so we're gonna come through the gate here, and if you guys look over right now, you can see up on the top of the pad is what we call our transporter erector. It's in the horizontal position. It's hydraulically lifted vertically and rotated down horizontally. Let me get through this.
The jury did its job. Mother to mother.
And actually, it was vertical this morning, and we just rotated it back down to do some work in the horizontal. The whole pad deck was cleared off. There was a mobile service tower that used to rolled into the center, and there was a fixed tower that all was cleared off when we got here. You can see these railroad cars. These came from over on Kennedy Space Center. We store helium and nitrogen into those rail cars as our main storage. As we come around the east side of the launch pad, you'll be able to see over to our side. You'll be able to see the flame tunnel. You can see we put an extension on our flame tunnel for acoustics, to cut down acoustics on the rocket as it's flying out. Another pretty interesting story on that. You can see that big LOX ball, we call it, the Bloxsphere. That came from, it sat over at Complex 37 over here where Delta 4 was for about 30 years. I think we paid $1 over scrap. Got it brought over here, and actually the thing was in pristine shape, and we hydrostated it and use it for our LOX system now. So we're coming around the flame tunnel.
Guilty? Absolutely.
I have a 1-year-old in me.
No, I think we put that on first launch. That extension we put on for Luger's launch. Actually, my lead technician underneath me, I have the best lead technician on this site, Kennedy Space Center and Cape. He designed it. Engineers, we stressed and strained it, and we put it on there. It's got a water cooling system. When we run, it keeps it cool when it's launching, and it saved us a lot of money from trying to put a concrete extension on there. Again, this LOX ball was it's probably I think it was built in the early '60s. Sat for 30 years, and we got a good price on it. That's it's kind of the way it is with SpaceX. What Elon told me 4 years ago, when I spend money, it should be feeling like it's coming out of your own pocket, and he's pretty tight on that. So the hangar coming up to is pretty much just a metal structured building that we got a couple cranes in there, and it's pretty basic. I mean, if you've been around a lot of Kennedy Space Center and other places, it's a little more, concrete and probably a little more expensive. But this is a prefab building basically with cranes in it. This pad was an excellent pad to start out with because it has a great infrastructure for running all your piping underground and through the tunnels, and just a beautiful pad to be able to start off with.
No. Yeah, I think
as we come up to the top here, you'll be able to see there was existing rails where the mobile service platform rolled in and out of. We used those exactly to go into the hangar. Actually, we built the hangar on top of the rails, and all our widths and everything. We got old rail car bogies that I think we got off eBay, and adapted all that to roll this transport erector into the hangar to get the rocket. And then once it's got a hold of the rocket, we roll it straight out to connect it to the launch pad and get over the flame tunnel opening.
Or I feel for the little girl, or I don't know what it is. I don't know what it.
So I think we're going to come out of here. I think the one group's going to go into the hangar first. I believe all y'all will follow me. We'll walk down towards the pad, and I'll talk a little more about the area and about the systems. and then we'll walk back over here, and then you guys will go inside the hangar and go look at the rocket.
Everyone understands. When you're out here on the pad, you can take pictures all you want. Inside, when we get inside to the hangar, we're under certain restrictions because of federal law. What it means for you are two simple things. You can't shoot up the back end of the engine. No pictures up the back end of the engine. No pictures down the front. There'll be people there to do it. But a lot of you guys have been pressing us for a long time for access. And we're fighting for access and we're fighting for remotes during the next launch. I guaranteed everyone that you guys are all going to do this. So the only thing is you'll get good pictures inside, just nothing up the back of the engine, nothing down the front. Sides will rotate it for you and try and get the decals up. Everyone clear? Come on down.
I thought you tightened it up.
Switching rights. This is called transporter record. We'll wait till.
This one looks badass.
I feel like a Armageddon roller. Okay.
No, I didn't give him the numbers.
Right. Anyway, Corps of Engineers is very expensive. We do a better job ourselves. Anyway, this is I'll let Neil do most of the technical stuff. I'll do the pretty shallow stuff because I was a journalist for a long time. This is the transporter rector. What you got it right now is you basically see it in its horizontal position. These rails that you see right here came with the pad. And what we did is we kept it up, we cleared everything, and we built this to fit. And what you see, it's down in the horizontal position. So when it's time to load the rocket, which is processed horizontally, we don't build it like the shuttle or like the Atlas is built. We build it horizontally. So what we do is we roll this back to the hangar, and you've got the rocket, which weighs 30 tons, empty, lift it up, we set it down, and these arms open up, we set it down, we clamp it, we move it back up, we bolt it to the 4 fixtures you can see over there, and then we raise it up. And that's where it's in position to be launched through that little square and the wires up above. The other thing that's very interesting, and I'll leave all the fluids, Neil is a fluid mechanical engineer, so he can explain how it all works and about how we can turn around rockets very quickly. But the thing is, once it's up, the coolest thing that I think about this rocket, and then I'll tell a story and I'll let Neil take it all over, was that from 0 minus 3.5 seconds to 0.5 seconds, we hit the engines. But there are pins in each of the 4 mounts that are holding the engine, that hold the engine back. And it's almost like a pilot on a runway revving up his engines before he lets go to take off. And what happens is while that engines are burning and we're holding the rocket down, it wants to go, we're running a computer analysis to make sure everything's optimal. If it's not optimal, the computer shuts the engines down. Now, when we had the first flight, the demonstration flight back in June last year, we started to cycle up, there was a problem when we closed down. And usually at all the other competitors around here, that would mean the end of the day. You fired up, you lost all your starters, you got a drain, you got a safe, and you got to figure out the problem. So you had all the Air Force guys packing up and going, well guys, I'll see you tomorrow. And SpaceX said, give us a chance. We'll be back up and running in 45 minutes. And they said, sorry, yeah, right. 45 minutes later, they launched. How it all works, I'm not going to go ahead. I'll leave it to you.
With your window though, aren't you going to have to make that window front with the ISS?
Yeah, that would be a little bit different on this next launch because the window is quite a bit shorter. Well, in the first flight, the window was quite a bit longer. The bottom line is we started up the engine. We had one low pressure on one of the gas generators, so we shut it off. The biggest thing, the reason why we can turn around so fast is to launch it because everybody has to say so and to do the data review and then making a decision on whether to try again right there.
So you don't have it like
So we shut the engine down. The engine shut down. It was we were 50 psi over a certain pressure margin. As soon as the engineer got all the data out, Elon's sitting right there. The guy that basically designed all the rocket engines was sitting right there. We figured out we'll probably just have a little bit of crust build up on our GUI system. It's called TTAP. Then we cussed it up, caused a high pressure. Raised the laser limit 50 psi. Set the limit. Increased to this Iron Maiden program in California where they ran it. This whole avionics system is here. It ran perfectly. Sent the software back, loaded the software.
And remember, there's every rocket's got 10 engines. 9 on the bottom, 1 in the upper stage. And every engine operates independently, and we can afford to lose 2 and still make it to orbit. The only rocket that was able to do that before was Saturn V.
Take it down aside.
Yeah, go ahead.
Hey guys, follow me. I'll get you a better view.
Yeah, I know.
Like I was telling you guys in the bus, like Bobby was saying, the rails are already here. Raise it up, just like Bobby said, up in the air, roll this in, open the clamps. We have a tug right now, just an old aircraft tug. Go into the hangar.
It's right there.
And then we'll lower it down, close the clamps. We'll roll out here to where the flame hole is. There's 2 flame holes there from the Titan. We used our south one, the north one. We have a big cover on it, so the blast doesn't come there. And the way this whole system rotates up is there's 4 hydraulic cylinders, two on this strong back right here, 1 on this side, 1 on that side. And then up on the launch mount, there's another hydraulic cylinder. You can see it hanging there. It's got a blue. It's got you can see the hydraulic hooks on it.
Oh, it's back there.
Yep. So those will extend out. And then this one right here will extend and lift this whole thing. Once you get over center of gravity, those will make contact on the ground. And these guys will quit pushing, and then those guys will just bleed. And then when you want to come back over, those guys will push, and these guys will bleed off. And it's all on a hydraulic system. It's all pretty much automated now. In the beginning, we did it manually, but got it all automated. You know, you got to go at certain rates and certain staging, and it's a forcing function, and you got to keep it slow enough that everything doesn't vibrate. But I think we've got it just modified it, and I think we can rotate up and down, going up in 10 minutes and come back down in about 12.
Right. So from loading it on to the transporter erector at the hangar and bringing it back out and getting it up, it's about 12 minutes.
It's pretty much basic stuff. I think most of the stuff is cost off the shelf items. We didn't really get anything special built. You know, you can see the stuff we got painted red is the remove before flight stuff. Pretty much follow typical aerospace protocol on remove before flight stuff. I made a note that these rail car bogies, some of them came from these rail cars that would be made stationary, and I believe some of them did get off eBay. So I don't know if that's an actual fact, but I just remember the guys joking about it that, well, just like I told you before.
And if you see the little turtles here on the ground, that's part of the plumbing system we were talking about flooding the pad. One of the reasons I said this, we took this pad is because it had a flame duct. We'll do the story about that. The only other thing I think to say is that the flight modifications or the movie modifications when we do Falcon Heavy, we show planning on doing 2013, 2014.
You could literally, if you have a big thunderstorm coming in, and say if the thunderstorm is in whatever your range is, you could technically take it down, roll it back, and roll it back.
Right, 4 minutes.
Within amazing time.
Elon wants us to be able to do
without any
get everything ready to fly in an hour. I think the best we've done so far is 8.
No, it's right. The pad will be cleared, there won't be a human out here. And the little black dog will be set. It's in the automation system, the doors will be
Part of the limiting factor is how fast you can fuel the tank.
Yeah. So you have to figure a quick way. You want to beat the other guys trying to beat you.
Now, are there any general soft questions that I can answer? If not, if they're technical and hard, direct them please to Neil.
Well, when you talk about modifying for heavy lift, are you seriously considering using this pad for the heavy lift as
Yes.
well?
Right.
Not 39B?
No, although we are in talks with NASA about 39B as well.
So are you going to deal with like flame trench issues and everything?
We would have to, because of the way the heavy lift would be positioned and how we might have to change it a little bit in terms of how we would.
My vote's 39.
They've played it
I
off
worked it
anyway.
up here. I think 39 A and B are Cadillacs. You know, I think they're.
So would you be able to put, you don't have to answer, it's an easy question. You put a manned spacecraft on there, say within years?
We
less?
expect to be able to launch humans by 2014. I mean that's now that we've
because
got
originally we were talking further out, and I did hear a rumor that somebody said 2013, and I heard it.
No, 20. I mean, the line was always 3 years from the beginning of the first payment, and
Right.
we were expecting a payment. Actually, when we negotiated COTS originally, we had an agreement for COTS D, which was human, that we wanted them to exercise a long time ago, but the issue became politicized. You guys want to just take it easy and not wander too far, please?
But once the shuttle is down, now you have more.
Well, I mean,
leverage.
we don't know, but the thing is, there's no doubt about it. Human space flight is NASA's baby,
Yeah.
and NASA's going to want it on the NASA side of the fence.
But it's
So, part of the argument NASA's talking about, and you really have to talk to NASA about this, but one of the ideas they're talking about is like a multiple user pad. And a lot of people who are in this are very nervous about multiple user pads because, someone goes out in the pad and then opens out how long it's out there. You're going to want your own needs. There's a lot of discussion chances are, my guess, if I were to I would put my money on a human space flight taking place from 39. And my guess is that's exactly why we would launch a Falcon Heavy from there. But then you start to get into issues. If it's an Air Force launch, and we're launching up to 39, who covers those costs? So, we work in the federal government system. There's turf and they don't want. That's down the line. But the plans are, even though he doesn't want to do it, the plans are.
SpaceX пытается создать в космос под ключ.
I don't think the Air Force has a huge problem. I think it's really, NASA has. There's a fence, and that fence might as well be the Great Wall.
Or are we talking Republicans or Democrats?
Who knows what the future is? I mean, right now the numbers just came out.
Yeah.
I mean, we really do sincerely believe that commercial crew is going to be the fastest way to get American astronauts back. I mean,
I think that's
with
great.
$19 million, forget about us. With $19 million, Boeing has done some amazing things with its initial thing. We are obviously furthest along. You know, the commercial crew, the budget from the House just came out yesterday. $312 million for commercial crew.
Right.
Those are kind of cuts that do not make it good.
I
That if
know.
we want to basically be, you know, not dependent on other countries, that's a paltry amount of money, and that's
and
an
NASA
issue.
has, I mean, not Russia has raised their rates.
Well, I mean, here's the other issue. The other issue is, I mean, our rockets for a Falcon 9 launch, it's $54 million.
Right.
That is almost a third of anyone else here. Even the Chinese have said they can't compete with our prices. The military is giving us a tough time about competing for military launches. So, I mean, they don't want to open things up for competition. So, I mean, we are basically deeply worried that between Congress shortchanging commercial crew and the military saying, well, we don't want to compete for lower prices, that they're going to strangle this nascent industry. And to be quite honest, I mean, everyone talks about American leadership in space. In the mid-1990s, there were 35 launches from the Cape.
Right.
And I mean the whole Cape, KSC and here. Last year there were 12. Part of the reason is that the commercial launches have gone overseas because it's cheaper.
Right, like they've gone to.
Because of our pricing, we have started to attract back international launches. We've got SES, we've got TICOM, we've got the largest commercial satellite deal ever done, which is Iridium. Right, we're bringing back launches to the U.S. I mean, and this is all with a very modest goal. I mean, I think American leadership in space is a combination of government and commercial working together. And unfortunately, a lot of people in Congress are married to the old way.
So how busy is this path going to be? I mean, can you talk about next year, the year after?
We are expecting by 2015 to have 10 or 12 launches a year.
From this pad?
From this pad. And we will have a pad at Vandenberg, which will be capable of Falcon Heavies as well. And we'll have also supposedly here, or 39 also Falcon Heavies. So that's what...
What is this? Is this some sort of deflector of noise?
Well, that's part of the acoustic. That's part of how we it's part of that $65,000 program that ended up working in the trenches, so that
There's
so
not
it's
water going through
the water. You can see the plumb lines. There is water going through all of this, and it comes off the edges like sheets, so it comes off as a wall of water. Now, let's start heading back in the other direction and get these other guys moving out.
How tall?
How tall? What, the lightning towers or the?
No, I mean the whole rocket.
180 feet with Dragon, about 200 feet with a fairing for a satellite.
Who owns this pad?
This is the Air Force.
Air Force owns it.
We have it's a multi-user pad, but we're moving over to a sole user for a gazillion years. And it's like a leasehold, freehold leasehold.
You're the tenant.
But I mean, that is the greatest thing. I mean, to get a rocket in and out of a storm.
But I mean, But what you'll see out here, what you'll see in Hawthorne, and what you'll see in the hangar is simplicity. And I mean, one of the things in being able to basically create affordable, sustainable. I mean, one of the things that's part of the problem. This is what Elon talks about all the time. When NASA talks about going on to a new program that uses shuttle heritage, part of the problem is it inherits a lot of the overheads of the old program, so it becomes very difficult to just cost down. People ask us, particularly the Chinese all the time, why are your prices so low? And the real reason is it was clean sheet development. It was developed from the very beginning to say, how can we make something that we can manufacture, control costs, and maximize reliability? So, it was conceived from the outset to be able to be affordable. Now, it was a little bit more expensive, I think, than originally intended, but still compared to anything else out there, including China's rockets, which was blowing the market open, we've now come back. And I don't know if there's any other U.S. industry that I'm aware of where the Chinese have said, we don't know how your prices are so low.
But the one thing you said, you have those other two engines, which if you needed those two engines to get off the ground, you've used those too, correct?
We are currently the largest rocket engine manufacturer in the country. We are soon to be, once the Falcon Heavy, because remember the Falcon Heavy is really 3 Falcon 9s.
Right.
So 27 engines.
27 motors.
Once that happens, we'll be the largest engine manufacturer in the world. And you have to remember, this was the first American-made engine in over a decade. And that's the other thing about this. This is an all-American made engine, except for the fact that some of the raw materials comes from bauxite mines in France and elsewhere.
Well, don't worry about. We won't take those pictures.
Anyway.
That you don't want.
Anyway, guys, Neil,
when's your
start
next
moving
launch
back.
from this?
We are hoping to launch from here later this year.
Are you going to put out like a press release?
Of course. It will be our last COTS demonstration flight, and it will be the first cargo delivery by a private company to the space station.
So then you actually do plan to launch and deliver to the...
Right. We will. What we'll do. The plan is we will. Dragon will approach the station. The robotic arm will grab it.
Right.
NASA doesn't want us going straight to it for reasons that I think are clear. It's going to grab it. They'll berth us. They'll take the cargo out. They'll put the cargo in, and we'll bring the cargo back. So and remember, a Dragon's the only system right now capable of delivering and bringing cargo back.
But if you have a manned system, then you could fire the thrusters.
The manned system,
Totally.
I'll leave that to when you get out to the capsule on the other part of the tour, Garrett will have the capsule there and he will explain everything about what we're doing to the capsule to make it, it's called the Dragon Rider program, okay?
The last comment, it's
The vehicle
impressive
we're
you see through that.
Yep.
I mean, the whole thing has to fit through that.
If not, it'll be a bad day.
So is this also COTS 2? I thought
COTS 2 and COTS 3 are supposed to be. Let's chase it out.
So about 99% here in this air-conditioned hangar, and only does it go out to the launch pad on launch day when we essentially use the 20-ton cranes to lift up the whole rocket, and we drive that transporter director that you just launched out there. Then those rails that we're walking along, and right now they're under these aluminum platforms. And we'll drive that erector in, we'll lower the rocket on, bolt it in, pull it out, and go vertical. And all that takes about 12 minutes to roll out. We've got some connection time to hook up the fuel and oxidizer, and then it takes another about 10 minutes to go vertical. The idea is, you notice out at that launch pad there isn't a lot of towers and vertical infrastructure. That's because the rocket is usually here. Now what's kind of neat about this facility, the first thing you notice is pretty austere. It's kind of purpose-built, steel structure, fabric vents. This is a very economical way to process the rocket. But there are some innovative things. So when we bring the rocket in, it arrives on a truck. It's towed by a standard diesel truck on a special trailer. We roll it in here and we lift it up onto these integration rails. And what this enables us to do is probably me and these two ladies, because it's on these frictionless rails, we could push this whole rocket back and forth. So we can move it like this using this pendant system. It's on these rings. So I can push these buttons and rotate it like a hot dog rotisserie, basically. And what that does is if I want to work on that number 9 engine, instead of having to climb up, I just rotate it down here, and I can, at its low point, the engine is about right here, I can just work on it right here. So I don't, the beauty of this is, on many launch pads, you got multiple levels. So first off, the comm always sucks, right? You can't hear in the headsets, the communication's garbled on all the multiple levels. Here, I just talk to guys because they're all standing next to me or just over there where those guys are. The second thing is I don't have to worry about dropping a 3/8 Allen wrench 240 feet into the engine section and breaking the rocket. And I also don't have to run up and down 16 levels. I just walk in here, walk up and down. So I mean, there's a lot to be said about this. I can have one toolbox. All the guys go work from. I don't have to have 8 different levels worth of full tools. So there's a lot to be said for horizontal process. Now, a couple ground rules here in the hangar. We've kind of got it blocked off so you can't, I don't think you can get into a position where you get in trouble. For ITAR, so this is the trafficking in arms, we can't take shots looking up the nozzle, so you can get side shots from here, but nothing, I don't need anybody reaching over and doing this. I can't look at that. And on the front end, we can't have pictures. You can look, but you can't take pictures into the mouth of the interstate. So when we get up there, I'll point it out. So real quickly, let me point out a couple of the key attributes of the Falcon 9. So as its name indicates, the Falcon 9 is named that way because it's got 9 Merlin engines. We started with a Falcon 1. Our founder, Elon Musk, got the idea that he wanted to build a rocket to help get a payload to Mars initially. He started with a Falcon 1, which was a single Merlin engine on a small tank. We've now scaled that single Merlin engine up to a 9-engine Falcon 9. So you got the 9 engines, you got a 12-foot diameter tank. It's about 112 foot long total. This booster is about the same capability-wise as an Atlas V with no solid rockets. So we're in about we can fill about the lower half of the market when it comes to launch. So, you know, one of the things that makes the Falcon 9 a player these days is the fact that we kind of lean on 3 main principles: safe, reliable, and affordable. So, you know, if it's affordable but not safe or reliable, nobody wants to buy your gadget, right? So you get safe and reliable are the key. So some of the things we do to make it reliable are, and rockets kind of have 3 main things that can go wrong during launch. The engines can go bad, your stages can fail to separate properly, so the first or second stage hang up, or your avionics, usually less so avionics can fail, so it can, you know, computer goes bad. So one of the things we did with the clean sheet design of the Falcon 9 is we made this engine out capable, so we can lose an engine during liftoff or all the way through orbit and still make orbit. So that's a reliability factor. Each of these Merlins puts out about 100 to 120,000 pounds of thrust, depending on how they're tuned. So you get about 1 million pounds of thrust from the first stage, and another 100 to 125,000 from the second stage. So what you get is about 10,000 pounds to geotransfer orbit, and that's 23,000 miles, and about 23,000 pounds to low Earth orbit. So think 300 kilometers, that's the space station orbit. So that's the capability. Now on the affordability front, we're the only guys that advertise their price on the internet. So go to SpaceX.com, there's the price. You know, Elon got his money in PayPal, so I think soon there will be a buy now button. Click and charge $53 million to your PayPal account. But I mean, that's important because if you look, one of the problems with the U.S. losing its position in the launch business is not so much that we've lost it internally, but we're losing business overseas. You know, so we're starting to win business that is traditionally, you know, U.S. satellite companies are paying to go to Russia, China, India, French Guiana with the Europeans to launch their satellites. They would prefer to launch it here. So the fact that we've got a 100% U.S. built rocket and it's about 1/3 to 1/5 the price of the competition on either side of this with Atlas and Delta, if you can get it safe and reliable, then it becomes very appealing. So we've had 2 successful launches, 2 for 2 with the Falcon 9. This booster is going to launch in somewhere in the fall, October, November is what I'm anticipating, depending on how the Dragon comes together and getting massive. But this idea that you can be safe, reliable, and affordable is what's going to change I mean, that's really what we're trying to get at. You know, with the shuttle flying out, you kind of have to think, wow, the space program is evaporating. Not really. What we're trying to do is retool it so that something safe, reliable, and affordable can do kind of the mundane. And you know, taking stuff to space station will never be mundane. But that's not where NASA needs to spend their bit. They should be exploring asteroids and going to Mars. Let's let them spend the money on that, and we'll just take care of supplying low Earth orbit. And eventually, this booster was built to fly astronauts. So all factors of safety are demand factors of safety. So when you're building a rocket, safety factors for demand are 1.4. For unmanned, 1.5. So we built everything at 1.4. Every Dragon capsule has 2 windows, guaranteed or no windows required for cargo. So we built this all on to fly flight crews. We're one of 4 companies to be awarded commercial crew contract with NASA for how you rate your booster and your capsule for land flight. Our big fab would put a launch aboard or launch station for Dragon to make a safe aviation rocket. couple attributes of the rocket engines themselves. So it's a fairly simple liquid oxygen RP1 engine. Single turbo pump using both quantities in the thrust chamber. The igniter is actually on the pad. That's pyrophoric. It hits air and light. So you have fuel, oxygen, and now a flame to get ignition. So this is your nozzle. This is a gas generator cycle engine. So we put about 98% of the thrust out the big nozzle and about 2% is let off in this gas generator. And that basically just keeps the turbo pumps at really high speeds. So those commodities. You can see two of the hold downs. So you saw the big hold downs out there, the hydraulic plants. That's what plant 1 or 2. You also probably saw liquid oxygen and fuel pipes coming in from the side face the pad. When the transporter is mated to the booster, it's got male ends, and these are female pregnancy ends. So the transporter will drive in here, and RP1, hydrogen, helium, and other gases will all plug in here. So when the thing goes vertical, you got the male and the female sitting on it. So the rocket fills in the bottom. So these are the pipes that will actually fill fuel on this side, liquid oxygen is up top. Tank the whole booster through these connects. And then when the rocket lifts off, there's no fancy umbilical or quick disconnect. It just lifts off, the plate closes, and it flies away from it. So very simple. What you'll notice about Falcon 9 questions down on this end? If not, we'll start walking up to the front of this. Did I understand you can say that the igniter was thrown off the ground? Right. For the second stage, we have the canister.
That was going to be my question.
Yeah. Hard to light those from the ground. That second
What's the usability? Is there, where does that fit into the scheme, or does it?
We do. I mean, Elon's very interested in reusability. Yeah, we I think reusability is part of our block 2. We tried the first 2 launches to recover the booster, and it's not built for it. It wasn't stiff enough, so we had to make some mods. Those are being rolled into the next revision.
Okay, so it's not imminent.
No, probably 6th or 7th launch, perhaps. This is going to be number 3. So
Okay.
now the tank itself is built of aluminum lithium.
Can we hear it?
Yeah, I would ask you not to put your hands on it, but you can see it's pretty stiff.
2195, 2127.
I don't know.
The external tank.
Yeah, it's aluminum lithium, but the booster is 85% built in-house. So we start with blanks, I mean just flat pieces, roll them into barrels, then weld the barrels together to make the tanks. We use friction stir welding for all that. It's covered, it's got cork on it now, and that's for heating as it goes through. So this is a common tank with fuel and oxidizer. So fuel goes up to about right here. That would be fuel. Then there's a common dome in here that separates this into 2 halves. And from here forward, there's liquid oxygen. So you have about 1/3 fuel, 2/3 oxidizer.
And the tape is for streamlining?
Yeah, I mean, basically close out aerodynamics, moisture intrusion. But this raceway here, there's one on the other side as well. carries the signals, the commands from the flight computer, which flies on the front of the second stage, back to control the nozzles, because all 9 engines are controlled separately, because if you lose one, the other 8 have to figure out how to accommodate the loss of that 9th. So
I've got a 2-part question for you. Talk about bringing contracts back to the U.S. and rockets. And like Airbus and Boeing both have situations where their planes get delayed and customers can cancel contracts, so they get major penalties they pay out to the customers. Is that part of your contract system as well, or
I mean,
you're just lucky not to have it?
most satellite customers want some kind of a backup plan if you can't launch them. So either our thing is we don't get paid until we launch, so there's an incentive on our side.
Sir, how far back do you want them to need?
No, we're
the yellow line, I
Yeah,
guess.
I'd ask you not to go past the tape. You can go if you want, and excuse me, you can go in here and take a shot looking up or back. Just be careful. The only real hazard in this hangar is that your feet don't trip over these rails or these grounding straps. But don't touch the composite, and don't stick cameras in the portals, if you will. You can take a shot like that, but don't stick it up in.
Can't you rotate a little bit so we can see the...
Nah, unfortunately I can't. It can rotate. You'll see at this interface we go from the aluminum lithium first stage tank to the inner stage. The inner stage is made of a composite. But the inner stage performs 2 main roles. One, it houses the second stage nozzle. So just the second stage flies a Merlin engine, much like that engine up front. It's still considered a nozzle. The nozzle is in that aluminum box right there. So it fills almost this whole volume of the inner stage. So it's 96 inches long, about gated or not. And that's because the second stage has to fire in 0G outer space, and flume expands significantly. So for the most efficient burn, use a large expansion nozzle. You'll also notice the separation system. So you see these metallic things located about every 20 degrees around the perimeter. Most rockets use explosive bolts or bolt cutters or explosive clamps to separate stages. But the problem with that, one, it has explosives. Two, when they go off, it puts a jolt into the capsule or the satellite. Most of those dainty electronics don't like jolts. Avoid it. So what we've done is built a pneumatic system, which is fairly unique to SpaceX. We use a ball and piston system so that each one of these things is it's like a socket, and the second stage would be a ball. So they would close around, and then when it's ready to separate, the computer says open up the sockets and then extend the pistons. These pistons would then drive out. And so instead of you just get a nice push the first stage away. This falls away and tumbles off. You wait a few seconds and then you light the second stage. So this is a 2-stage to orbit. We light the first stage, it burns for 3 minutes, we separate. The second stage burns for 5 minutes and you're in low Earth orbit. So that's another one of those reliability features. The fewer staging events you have to do to get to orbit, the better. Now, for that environment, it doesn't have a lot of stage system. It's a bigger C7 design, but we don't have the physical life support stuff built. We did. Pretty benign. No, we didn't. We were blockage. That can go. Yeah, we have 2 astronauts on staff. There's a long list of people that are ready to go. The company. off-site, it's maybe two more things. While this one's being ready for launch, we'll go prep. So as soon as this one goes, they will roll out. Pretty much the same thing we do here today. We have that capacity. Right, so we bring them out, they would already be pressure tested, leak checked, avionics will be ready, so you're really then just doing final integrations, connecting everything up. And you want rail cars? No, they come over the road on a truck. Yeah, if everything's ready, you're talking somewhere on the order of 20 days. You know, and that's build it, roll out, and fuel it, roll it back, make sure it's good. We do a hot fire on the pad, so we light the engines, 5 seconds burn, a couple days burn on. So we're talking, yeah, we get about 23 days. Yeah. You're right. Yeah, this would fall off and re-enter into the atmosphere. Yeah, ultimately, the first stage, second stage, encapsulate. We're not there yet. Even the first stage, it's going to come back. We want to recover it. This is a challenge. Yes, I mean the business plan is built on recovery. Recovery is really
Take pictures.
big step to getting launch affordable.
Is that really deployed?
Yeah.
So that's the place to go. So you can pick the plane. Right. You go to the bus and then you go to the LCC.
Okay, guys, let's go back to the bus.
It's got Henderson.
Okay, let's head out.
Yeah, this is the.
He is
wrap it up.
Director of Safety and
Okay.
Insurance. So far, we have 15 launches on contract with cargo. We also have about 40 launches on the books, including cargo space station, but also commercial satellites. Our plan is okay, folks. There's summer, you've got mustache. Okay. It's a wrap.
Go back to the same bus. Thank you very much.
You're welcome.
Thank you very much.
Right.
Trash is right there.
Trash.
Right there.
Said something about hydraulics. I don't know if it's your guys or.
Put it in there.
Thanks, y'all.
No problem. We have 2 astronauts in actually NASA.
Never been in here before. This is my first time too.
Former NASA astronauts. Right, shuttle astronauts and space station as well.
I don't know how they're going to fit the 9 heavy in here.
NASA astronaut office.
And we'll let it go and it'll bring cargo back. We'll be ready on September 30th. We think that everyone
Okay,
wants
she
to.
said no already.
The side of the engines are okay. But we gotta go.
Yeah, come on guys, gotta go. Let's get
No
to
more
your bus.
side views.
Thank you very much. You're welcome.
Thank you very much.
Thank you very much.
So much.
Alright, everybody. I'm Kristen. I'm the spokesperson for SpaceX. You all got to meet Bobby, who's just here.
This, you can't see him, but astronaut Garrett Reisman, he's our project manager for the Dragon Rider program to upgrade the Dragon space capsule to carry astronauts.
And yes, I am standing up, so don't
We've been in the shuttle. We know it's small.
What we're going to do is we're going to just walk you through our Launch Control Center. SpaceX is set up where our launch control is here. Our mission control is at our headquarters in Hawthorne, California. Much as NASA's Launch Control Center is at KSC and Mission Control is at Johnson Space Center in Houston. We'll walk you through the Launch Control Center and then we'll take you over to the Dragon spacecraft. This is the Dragon spacecraft which in December 8th of last year we launched. It orbited the Earth just about 2 times and it landed in the Pacific Ocean, making us the first commercial company in history to launch, orbit, and recover from orbit a spacecraft.
In the top.
So dude, finally, a face to avoid.
Well, just go right out to the Dragon space capsule. It's the one that looks like a toasted marshmallow from the heat of re-entry. Hey.
Oh, okay, there it is.
More of it just is easier, more cost effective. There's times where automatic control might actually be more difficult than just let the guys fly it. So we're going to do what makes sense in each phase of flight.
Do they use 3 parachutes like the Apollo?
Yes, this Dragon landed with 3 chutes.
Sorry.
And they give it a pretty nice general descent. In the future, then we're actually looking to eventually evolve to propulsive land landing. So landing kind of like the Webb did on the surface of the moon. We're looking to get it like the Russians now. No, the Russians still come down with the parachute with the Soyuz. They just have a little bit of jet firing at the very end, pushing it a little bit, and we might start out with a similar situation. But eventually, we want to eventually get to the point where we don't need to use parachutes at all for a nominal land.
How does the size of this module compare to the same all?
That's a good question. It is taller. I'm not sure about about the diameter. So this is 12 feet. I'm not sure what but yeah, we do stand considerably higher. So the structural design of it is actually 2 thrusters, and then the cylinder in the bottom. And it looks like a gumdrop kit from the outside. That's because the surface section is covered up and filled up with hardware. You can basically look inside that where the panels are removed. You can see the actual structure, but the interior volume is pretty roomy. And once you put some people and all the related equipment in there, it's gonna get a little tight.
So this can carry
we designed for something. The amount of space inside? Yeah. This will be more cramped than the shuttle.
Oh yeah,
It's going to be small. Exactly.
That might be a giant.
Yeah, it might be too big. We might have to. We plan to pull the full range of NASA astronauts that are in the Corps. So even the 6'4" guys that we have now, well, we'll kind of again the hair. So we're not going to preclude anybody from flying.
When you launch this, do you have a lot of weight in it? Do you have some weight in it?
No, it didn't have, actually the only payload, the only way with this side was some cheese.
This next flight will have cargo.
Yeah. The next flight is the next flight is going all the way to the space station, and it will carry cargo, and then all the subsequent flights will be cargo flights that will be all to the.
Are there going to be any tests of this prior to actually trying to go to SpaceX? So that's
The very next flight, the objective is to go to the space station and deliver cargo and bring some stuff back. So.
And we're the Dragon is the only craft capable of not just delivering, but bringing cargo back.
Where will the station arm grab?
There's a GNC bay, which is around the other side, and there's a door that deploys, and when that door opens up, the grapple picture, you don't want that sticking out in the wind for launch. So the grapple picture actually points inward for launch. The door opens up, and then the grapple picture is exposed. And so it's just around the other side, about this high up the hole.
How many are in production?
Let's see, there's the one that's about to launch, and then we have about 2 more in fabrication right now. So there's about 3 in the assembly line at any given time. Up on top is a CBM, common burn mechanism. So the same exact burn mechanism that all the space station modules had. So the hatch opening will be exactly the same as between any module.
So the link up is going to be
Yeah. That lifting collar is not split like that's just to transport the vehicle. Where that collar is, just on the other side of that would be the common berthing mechanism.
And where will the launch escape system? Where are we going to put that?
That's a great question, Bobby.
Thank you very much.
The launch escape system is going to be a total of 8 different engines in pairs of 2. So there'll be 4 pods, each pod having 2 engines, and they'll be spaced out in each quadrant around the outside. So there'll be bump outs sticking out into the wind a little bit from the sides here, and that's where you'll have your launch. So basically, it's going to be a pusher design for the launch board, as opposed to everything that's been done in the past, which has been a tractor design. So if you guys have seen launch abort systems in the past, like Apollo and Gemini and the Russian Soyuz, it's a tower on top of the rocket. The thing about that is it has to work every time for the flight to be safe. You have to jettison that tower. So that's an action you have to take for it to be safe. The big advantage to having it side mounted is that it's kind of like the way they've done it in the past. It's kind of like having to use your ejection seat every flight. It has to work every flight to be safe. The idea is here you don't have that event. So the other nice thing about it is it's reusable. So you just fill it up with gas and you're ready to fly it again, and you bring it right with you. You don't throw it away.
Right, so it's like building a whole new rocket and throwing it away for every flight.
Exactly.
Is this capsule going to be used again?
Yeah. This guy, no. This is our favorite. We have this capsule occupies a very special place in our hearts, and it's going to end up in our factory in Hawthorne for all of our SpaceX employees to have and hold.
Where is Hawthorne, California? Where near? What's this?
Very close to LAX. We're very close to Los Angeles Airport.
So do you have to be one of the first?
Boy, we're still a long way away from deciding that, and I keep joking that we need to put like one of those bakery machines, like take a number in the cafeteria, because we got plenty of people at the SpaceX that want to jump in and fly it. But that's something we don't even know if it's going to be a SpaceX pilot or if it's going to be a NASA astronaut that, or maybe a mix of a joint test team when we start doing test flights.
Rent the job out,
right? And then the Soyuz, and even then the shuttle. But time will tell.
How many cubic feet of cargo? If you're going to fly this again, you obviously
Oh yeah. To fly again. That'd be clear in our NASA contract. They're asking for a new vehicle every time. So we're gonna have a bunch of these to play around with, which is really nice because we can use that for testing, and potentially we could refit it and fly it again. But you're right, we would have to do some refitting. The heat shield, actually, if you notice, is it got very little ablation, so actually it's in pretty good shape. And we did, if you notice, there are things missing, and we definitely looked at the effect of salt water on the thrusters, and we took some of those thrusters back to Texas and fired them again to see if they still worked. And so far the results are very, very encouraging about the work that would be required to turn around and fly again.
Shield is the life support system in-house?
Yeah, we haven't made that decision yet. We're designing it right now. We have a couple. Well, we have one company that's a partner with us right now, Paragon, that does Eclipse. But we haven't, basically right now we're at the system conceptual design phase. And once we define exactly what system we want, we will look around on the outside to see what people would charge us to buy it from them. And then we'll also consider building it ourselves. So that make or buy trade will be something that will be a conclusion of this one-year design effort that we're currently undertaking.
You were going to put this in your own facility in Hawthorne.
Yeah.
Is the Air and Space Museum been interested?
You know, yeah, we did have some contact with the Air and Space Museum, but they wanted to charge us a lot of money to exhibit it, and so we decided, hey, you know, we kind of like it, and we're not going to charge us anything to keep it. So,
how many launches per year will you aim for?
Eventually, we want to launch Falcon 9s at a rate of about 12 per year. That'll be our full up once we get the assembly line up and running.
Now this vehicle presumably, having cargo is automated control.
Yes.
But you mentioned the pilot. What would the mix be of automated and
Our plan is for most of the control modes to be automated. We will use manual capability as a backup when it increases safety and adds redundancy. But we're also, if there are regimes of flight that the automated flight control is actually more difficult or less cost effective, then we'll consider using manual flying as primary.
And just everybody, we're going to put you back on the bus in about 5 minutes. So if you have more pictures to take, get them now.
How much does the simplicity contribute to your being successful?
Well, you know, the simplicity contributes not only does make successful, but it adds a lot of reliability and safety. So the people ask, well, how can you be cost effective and also safe? And we use that.
It's now a museum, and we take people, we give them the whole 60-year history.
So make it as big as you can make it with it. Whatever
NASA has
you can get.
launch pads. There are 50 in here. NASA's able to 39 hang 39. That's it.
Update
That's it. They're on property. We built some of this stations with it.
And there are conversations about it with my kids. Design and test. And 300 million.
Yeah, we're in the industrial area now, in the middle of the.
But it's a big 1 million pounds worth.
You see this hangar here? There's one called Hangar R. Anyway, all the missiles from the 1950s are in there.
Halfway submerged.
There's like Snark and Matador.
Imagine
and
sound pressure.
Omar.
Breaks the water. Try and get the decals up. Everyone clear? Come on down.
中に入ったら
Switching rights. This is called transfer record. We'll wait till.
Just trying to look as badass as possible.
I feel like Armageddon roller.
No, I didn't give him the numbers.
Right. Anyway, Corps engineers is very expensive. We do a better job ourselves.
I'm trying to put a concrete extension on there. Again, this LOX ball was, it's probably, I think it was built in the early 60s. Sat for 30 years and we got a good price on it. That's it's kind of the way it is with SpaceX. What Elon told me 4 years ago, when I spend money, it should be feeling like it's coming out of your own pocket, and he's pretty tight on that. So the hangar coming up to is pretty much just a metal structured building that we've got a couple cranes in there, and it's pretty basic. I mean, if you've been around a lot of Kennedy Space Center and other places, it's a little more, concrete and probably a little more expensive. But this is a prefab building basically with cranes in it. This pad was an excellent pad to start out with because it has a great infrastructure for running all your piping underground and through the tunnels, and just a beautiful pad to be able to start off with.
No. Yeah, I think
as we come up to the top here, you'll be able to see there was existing rails where the mobile service platform rolled in and out of. We used those exactly to go into the hangar. Actually, we built the hangar on top of the rails, and all our widths and everything. We got old rail car bogies that I think we got off eBay, and adapted all that to roll this transport erector. My name's Neil Hicks. I'm the fluid systems manager. We started here 4 years ago when there wasn't anything out here, and me and another guy pretty much designed all these fluid systems, and took this nice launch pad and adapted it for a Falcon 9.
He's always making fun of me with the belly button lit. I think it's the shirts I wear and the fact that I have hair on my belly and she doesn't. My theory. And somebody told me once that
He's got the radio.
More belly button like that is because as you get started and you got the hair.
All right, so we're yeah. Like what? All right, so we're gonna come to the gate here, and if you guys look over right now, you can see up on the top of the pad is our what we call our transporter erector. It's in the horizontal position. It's hydraulically lifted vertically and rotated down horizontally. Let me get through this.
The jury did its job. Mother to mother.
And actually, it was vertical this morning, and we just rotated it back down to do some work in the horizontal. The whole pad deck was cleared off. There was a mobile service tower that used to rolled into the center, and there was a fixed tower that all was cleared off when we got here. You can see these railroad cars. These came from into the hangar to get the rocket, and then once it's got a hold of the rocket, we roll it straight out to connect it to the launch pad and get over the plane tunnel opening.
Or I feel for the little girl, or I don't know what it is. I don't know what it.
So I think we're going to come out of here. I think the one group's going to go into the hangar first. I believe all y'all will follow me. We'll walk down towards the pad, and I'll talk a little more about the area and about the systems, and then we'll walk back over here, and then you guys will go inside the hangar and go look at the rocket.
Everyone understand. When you're out here on the pad, you can take pictures all you want. Inside, when we get inside to the hangar, we're under certain restrictions because of federal law. What it means for you are two simple things. You can't shoot up the back end of the engine. No pictures up the back end of the engine. No pictures down the front. There'll be people there to do it. But a lot of you guys have been pressing us for a long time for access, and we're fighting for access, and we're fighting for remotes during the next launch. I guaranteed everyone that you guys are all going to do this. So the only thing is you'll get good pictures inside, just nothing up the back of the engine, nothing down the front. Sides will rotate it for you.
Around Kennedy Space Center, we store helium and nitrogen into those rail cars as our main storage. As we come around the east side of the launch pad, you'll be able to see over to our side, you'll be able to see the flame tunnel. You can see we put an extension on our flame tunnel for acoustics, to cut down acoustics on the rocket as it's flying out. Another pretty interesting story on that. You can see that big LOX ball, we call it, the Bloxsphere. That came from, it sat over at Complex 37 over here where Delta 4 was for about 30 years. I think we paid $1 over scrap, got it brought over here, and actually the thing was in pristine shape, and we hydrostated it and use it for our lock system now. So we're coming around the flame tunnel.
Guilty? Absolutely.
No, I think we put that on first launch. That extension we put on for Luger's launch. Actually, my lead technician underneath me, I have the best lead technician on this site, Kennedy Space Center at Cape. He designed it. Engineers, we stressed and strained it, and we put it on there. It's got a water cooling system. When we run, it keeps it cool when it's launching, and it saved us a lot of money.